Writing double replacement reactions. First of all, we need to get the words into symbols. So sulfuric acid, we know it's H2SO4. Because it tells me it's dilute plus it's acid, we know that it's an AQ. Then it also says it reacts with a solution of barium acetate. So we're going to add barium acetate. Barium has a charge of +2, and then acetate is big A, C2H3O2, which has a charge of -1. So we're going to need a 2 down at the bottom. So that also is AQ, because it tells me it's a solution. So what's it going to form? Well, I'm going to write down at the bottom the products. So I'm just going to write the complete reaction to start with. So it's just a double replacement reaction. And so what's going to happen is I'm going to get some barium sulfate. Barium again +2. Sulfate is -2. So therefore the +2 and the -2 cancel out. And I'm going to get some acetic acid because the H is +1 along with the acetate, which is -1. And so that is acetic acid. So then my next step I need to figure out is the net ionic equation. So first of all, I need to look at the barium sulfate. If I refer back to my solubility rules, sulfate is one of those that you kind of have to memorize. It's usually soluble, except with some of the group 2 guys, so barium and calcium, and then with sulfate. So I know that this is actually going to form a precipitate, so it's a solid. And then also, I know that acetate, even though it's AQ, I'm going to make me a little note, it's weak. It's one of the weak acids. It's not one of the members of that strong acid club. So it's weak. It doesn't ionize 100%. So because of that, when I look at this reaction, I really don't have to cancel anything out, because being a solid, the solids do not ionize, and then the acetic acid doesn't ionize. And so this reaction is actually written as is. And so if we then look at the question, and so on the AP test, they'll ask you to write a reaction and then to answer a question. And this one says identify the spectator ions in the reaction. Well, there's no spectator ions because nothing breaks apart. And so that's what you would state, that there are no spectator ions. Okay, so now I want to do an additional question. So in this one, in number 2, now I have a solution of sodium phosphate. So we're going to do the same steps again. So sodium, Na, is in group 1. Phosphate is PO4. Got to have those memorized, with the -3 charge. And because of that, that's going to require me to have the 3 down at the bottom. So Na3PO4. And I'm just going to leave the charges up there for right now, but when you write a complete reaction, when you're all done, you won't have necessarily the charges in a compound. It tells me that that's a solution, so an AQ. And now that's going to react with another solution, calcium chloride. So again, calcium is +2. Chlorine is -1, which requires me to have 2 chlorines. And again, that's an AQ. And then they're mixed, and so it is, again, a double replacement reaction. So calcium is going to bond with phosphate. And when it does that, we need to balance the charges, and so we get 3 calciums and 2 phosphates. And then the result also left over is some sodium chloride. Na is +1, Cl is -1. You always write sodium chloride salt. It's just NaCl. So now I need to decide, what are these guys? Well, I know that most phosphates, it's part of that CHOPS, so most phosphates are not soluble unless they're with an alkali metal, group 1. So I know that this is going to precipitate and make a solid. And NaCl is going to make an AQ. So now in this case, I do have things that get to cancel out. Anything that is sitting in an AQ will be gone. that's on both sides in an AQ. So if I look, I can see that sodium is in an AQ on this side and sodium is in an AQ on that side. So it's going to cancel out. And so I won't write it, I'll just write the PO4. So now I'm going to look at the calcium chloride. And then I look, calcium sitting in the solid, so I don't cancel that out, but the chlorine is sitting in an AQ, and this chlorine is in an AQ, so I'm also not going to write that. I'm just going to write the calcium. And pretty much in a precipitate reaction, the only thing that you're going to write down are the ions that result in the solid. So then I have to balance because this has 3 calciums and 2 phosphates. And so that would be the reaction. Well, in this one, let's kind of refer back to the previous question. If it asked me for the spectator ions, my spectator ions would be the guys I didn't write down. It would have been, so I'm just going to kind of note that my spectator ions are going to be the sodium and the chlorine. And then looking at the question, this is what's the most likely color. If you look out on Moodle, I have a little paper that's called Colors to Know, and it has certain precipitates. And so what we would find, some calcium phosphate is actually a white solid. So you would see a white solid precipitate floating in a colorless liquid, okay, in water. So that's what it would look like. So that's what the resulting mixture would look like. Okay, so then the last one I want to do is an acid-base double replacement. So if we take a look at, again, the reaction, we need to get it into words. And so it says lithium hydroxide. So lithium is +1, hydroxide is -1. So it's just lithium hydroxide. It says it's a dilute solution, so again, I know it's AQ. And that's reacting with some hydrobromic acid. Hydrobromic acid, something important to remember about hydros is that if you see a hydro, then there's no O, it's just H and a buddy, HBr. And again, he is AQ, but I'm going to make a little note. He is in the club. He is a strong acid. I'm also going to make a little note about lithium hydroxide. He's also strong base because Li is in group 1. So anything in group 1, group 2 will make strong bases. And then remember, you have to remember the 6 strong acids, and HBr is one of those. So then I'm just going to write the reaction. And so again, a double replacement reaction, but pretty much a neutralization reaction where I get water, and then the remainder, what's left over is lithium and bromine, both 1 and 1. Lithium's +1, Br's -1. The deal is on this one is lithium bromide is actually an aqueous salt because lithium is in group 1. All group 1 solutions, all group 1 compounds will dissolve in water. So then because both of these are strong, the bottom line on a strong acid and a strong base reaction is that you mark out the metal and the non-metal and strong acids and strong bases when you write the net ionic. So in this case, lithium actually is going to go away, and I'm just going to have OH minus. And then hydrogen's going to go away because, again, it's strong. So I'm going to have Br minus. And so it's just going to make, oh, see, made a quick mistake there. Never get rid of the H and the OH. I'm just going to have H plus. And so I'm going to get H2O. And that's what you always get when you have a strong acid, strong base reaction. So you always just get H plus, OH minus, makes water. And water's a liquid. Now, what if it wasn't? What if it would have been HF? Okay, so I'm going to just rewrite this reaction. And if this reaction would have been reacting with HF instead of HBr, HF is a weak acid. So, again, still strong base. In this case, I have a weak acid. I'm still going to get water and a salt. The salt in this case is going to be lithium fluoride, and that's an AQ. But the deal on this one is that weaks don't break up 100%. And so I would get the OH minus because lithium would be gone, but HF you still keep together. And because of that, on the other side, I'd get my H2O. But in this case, I'm going to keep the F, because the F cannot cancel out. The lithium will be gone, but I'll have an F minus as my AQ. So I cannot cancel it out. The only thing that would cancel out would be the lithiums. So that's why that reaction's a little bit different when you have a weak acid versus a strong acid in this reaction. So if I went up to the top there, it says which of the reactants solutions would feel slippery on the skin, and the answer would be the lithium hydroxide, because a property of feeling slippery is basic. So this is just the completion on writing double replacement reactions, precipitate and acid-base reactions.